Yeah, we can hear you.
Is it coming from speakers or is it coming from speakers? Okay. Otherwise it was a little too loud. All right, so I don't know how many of you looked at or know what GraphQL is or looked at the website since the topic was posted. I don't want to just essentially say everything that's in the learn section there, but I would highly encourage you guys to go read through those pages. They're very informative. Read the spec, it's pretty short. That should give you a little more in-depth after this talk. But first I want to kind of breeze through some concepts, and then most of the time I'd like to be in a working demo. I have some checkpoints that I'll kind of move through in the demo so you can kind of see it evolve over time. What is GraphQL? So from the official documentation, it's a query language for APIs and a runtime for fulfilling those queries with your existing data. GraphQL provides a complete and understandable description of the data in your APIs, gives the client the power to ask for exactly what they need and nothing more, and makes it easier to evolve APIs over time and enables powerful tools, developer tools. And then I added a little blurb. It's also a standardized language for describing entity relationship models, or it can be. It doesn't have to be restricted to just representing your data. You can dynamically generate things if you want to. And then there's also kind of a blooming ecosystem of tools, libraries, and frameworks. One of which is a tool that I actually wrote, so we can mention it a little bit later. It's fairly popular in NPM. Yeah, it came out, I think, in 2015 by Facebook, but it wasn't really widely announced until like the summer of 2016, maybe spring. And I know at our company, I read about it from some blog posts, and I implemented it. Well, I went, and a week later, we had a working version. Well, I didn't spend a week working on it, so we did it that day. A week after reading about it, we had it working for our stuff. And I thought that was pretty cool. What isn't GraphQL? It's not a database abstraction, although you could make one using it. And it's kind of a common usage. It is not a DB query language, unless there's plugins for Mongo and other things that you can write GraphQL instead of SQL or Mongo query language or whatever the DB language of choice is. Or there's layers that can go on top of things. It's not a complete server framework, although there are many plugins that make it very close to that. There's ways to do it for Express, Happy, Koa. That's just in the Node world, and then there, etc. And then basically for any language you want, there's a library for that. And then there may be frameworks on top of that. And it does not solve all your problems. Solve many, especially if you're writing RESTful APIs. So, some concepts. At the core of what GraphQL is a schema. And what that is if you ever looked at an ERD, an entity relationship diagram before, this image here should look really simple compared to probably some of the things you've seen. But it should look familiar in that we have fields, and then we have a type. So there's a variety of types, including scalars, which would be inflow, string, boolean, custom objects, which would be like the user table here, lists, non-nulls, which basically make things required, enums, and then there's some more exotic ones as well. The exotic ones are interfaces and yes. Yep. Well, non-null. That's what it means. But essentially it means if you get a user object, it will always have an ID. And I'll get to it a little bit later, but there's also ways to have arguments to fields, and you can make arguments be non-null.
Is it convention in GraphQL to use a string instead of an integer for primary key?
It's up to you. It does not make any of those decisions for you. GraphQL, you can think of it as just a layer on top of whatever your backend is.
I was just wondering if for convention, currently, do you see one or the other?
So I know at my work I like to use UUIDs, so that's probably my habits coming through here. Other people come from a more relational world, probably use auto-implementing managers. It's really up to you. Okay, yeah, feel free to ask any questions as we go along. There's the concept of operations, which there's two. There's query, which is a read-only fetch, and then there's also mutations, by which you can write data and then get the result back via fetch. I'm going to mostly be talking about querying. I may mention a few things about mutations along the way, but if you're curious about that, read the docs. Okay, so I mentioned the query operation. So at the root of your ERM, your entity relationship model, there is a query object. You can actually have more than one if you want, but the convention is to have one and call it query or root or whatever. And in there, it's kind of your entry point. So you define your fields, and then from there you have relationships to your other entities. So in this case, we have a root query, which has a field called users, and if you fetch that, you'll get an array of users. Or you can call a single user and provide the ID argument, which should be a non-null string, so it's required. And then you will get a user or a null if it doesn't return a result. A selection set is a core concept to issuing queries, and it's the way that you tell GraphQL what data you want back. So back over here, the user has various fields, but in your query, you can specify all or a subset of them that you want back, but you have to explicitly specify what you want. And so that's kind of one of the features of GraphQL, is that it forces you to ask for what you want and nothing you want, which is, it's nice for the backend, because then you're not kind of beholden to people using it freely and see what people are doing. And on the front end, you give some guarantees about what you want to be supported into the future. And there's also ways, actually, to flag things as deprecated, stuff like that. So if you're providing some public service that lots of people consume, not just your tools, then there's ways to communicate that outside of sort of the tools. Okay, so this is an example of a query, and it says users, which means from this model over here, get the field called users, which should return an array, and then you're saying what the projection is, or what fields you want for each item in that array. So each user that gets returned. You want the ID, first name, last name, and everything. There's things that you can have in here are fields called fragment spreads, inline fragments. I'll get to some of that a little bit later, but some of that's a little more advanced. Okay, so a field is what a selection set is primarily composed of. A field describes one discrete piece of information available to request within a selection set. Some fields describe complex data relationships to other data. In order to further explore this data, a field may itself contain a selection set, allowing for deeply nested requests. What that means is a field may point to another object or an array of objects, or be one of those more exotic types that I mentioned, not just a scalar. All GraphQL operations must specify their selections down to fields, which return scalar values and ensure an unambiguously shaped response. And what that means is you can't request an object and not specify what fields within that object you want. And likewise for a list of objects. Okay? In the demo, all this should become much more concrete. You can have arguments to fields, and they can be required or optional. The arguments have types as well, the same way that your fields have types. But when they're specified, they're unordered and types. So this would issue the query where you say, I want the user, the ID 1, and give me these fields on it. Okay, so you might have noticed that if you can ask for a user, you might want to ask for more than one user specifically. So that's where field aliases come in, where you can basically rename a result set to something in your result file. So if you did this, you could get both user 1 and user 2's email in one request. Which, if you've ever written REST APIs before, you would know that typically you have to either make a couple of requests to get this kind of information, or get a list of things, or provide some sort of query via arguments to get it down to just these things, depending on the complexity of your API. But here it's very nice because you can get these things, you can rename them to whatever you want, and they are right there in the result. And typically, the GraphQL servers return JSON. So I'll show a bunch of queries and results later, but in the JSON body, it would have basically an object which has a key called data, and then inside of data would be user, and that's an object that should have an email, user 2, email. Okay, so you can imagine if you have a complex schema with lots of fields on your various entities, that would get pretty tedious to specify, especially if you're wanting to fetch a lot of things at the same time. So that's where fragments come in. This is a named fragment. There's also ways to do inline fragments. It's basically a reusable projection that you can then specify inside of your other selection sets. And you can mix fragments with field selections as well. It's not showing that here. But what this would do is, I want the list of all users with those fields, and I also want the user with ID1 with those fields to be specified. Which is nice when you want to kind of make concise, reusable things, not to concatenate strings together. Yeah.
But to jump right ahead, but could a fragment take like arguments like if you wanted to get, maybe I'm missing from here, but like if I wanted to use that user fields to get particular usage.
Sure. Can you rephrase that?
So like you've got user fields inside users there, right? So if I was getting, can you use that? Never mind. I needed to reread. I needed to reread your example, and all of a sudden it makes sense. My question's wrong.
And like I said, you can mix fragments and field selections. So let's say email wasn't in this thing, but you wanted the email for this user, but not for these users. You could say user fields and email and vary it. Or you can also mix multiple fragments together.
The issue I was having was I didn't realize user fields was just expanding a list of fields inside of something else. I thought you misunderstood it to be that was a way of querying for a user. And I was like, okay, so how do you say which ID?
Yeah, it's just a reusable projection. Yep. And there is a concept of variables as well. So you can declare in your query what variables it accepts, and then use them within your query, and also within your fragments. And I think, I'm not sure about the syntax for that, but I think you provide it to your fragment, but it's in the docs. And then you also provide an object, which is the key value pairs of your variables. In variables, the keys are strings, but the values can be of varying types. Well, they can be scalar types, or they can be enums, or you have to declare if they're going to be an object or a list of objects. There's a way of declaring the type there. So you could imagine that you have a really complex query, and you want to make it completely reusable, and you don't want to code the logic into your application for concatenating all these strings, because you notice it is its own thing. And while it's not very hard to generate, it does take some custom code, unless you're reusing one of the myriad tools out there already. But you can just have this, and then you provide your variables along with your query when you make a request, and the server does the work.
So do you pass the query as part of what you're setting? Because in the other example, you would pass the previous GraphQL queries. You pass this query, or do you just pass the user with variable function name, so to speak?
You pass the query.
So you pass the whole
and
thing, so.
your variable values. Yeah, there's no like stored procedures or things like that. Although you could argue that fields that accept arguments are essentially that. Okay. So that was sort of discussing schema and queries. Another thing is that the schema itself is introspective. You can do introspection. And so the schema is totally queryable. You can query it the same way that you query your models. And this is really useful because you can use it to power all kinds of tools. So that when they talk about powerful developer tools, this is what they're talking about.
It's like a collection of
Yeah, except that it doesn't need your actual classes. It can hit the endpoint to get the full description of your full schema. And there's a bunch of tools. Like my tool basically, well, is used to generate these types of diagrams. And all it does is it uses the introspection result and then looks at this stuff and generates the dot file that you use to grab this to compile it to whatever format you want. And then there's other IDEs, or some IDEs support it themselves, or there's also a thing called GraphQL, which is kind of an interactive place where you can type it out, nice syntax, so you don't have to worry about escaping stuff and making the actual post or GET requests to try things, which I'll be showing you in a little bit. But just know that the introspection stuff is super cool. And then I mentioned mutation. I don't really want to do that. Okay, so we're approaching the demo part of the talk. And I wanted to share some links here. First of all, over here, I made this web app back when I first found out about GraphQL. And it's fairly popular actually, but it's a little more manual than some of the other things that have come after it. But here is the introspection query. And this is basically everything that you need to find out about what entities are available, what their fields are, what their types are, and all that stuff. Take that, run it against your API, paste it in here, and it will generate a DR lead for you. So let me make this. So the examples that they use in the docs are from the Star Wars API. They put a GraphQL abstraction on top of the existing RESTful APIs, and this is what happened. But it's pretty cool. You can query films via various arguments there, or if you know the ID, the IDs are actually enum, so you don't have to know the strings, but it's basically the same. People, planets, species, starships, vehicles, and then there's this sort of like node stuff. And so there's various ways of getting things. You can list you can get a single film this way, or everything's pretty much paginated. So if you hit a thing that is supposed to return a list they call films, you get a link over to this films connection. Can you see my cursor at all? Films connection thing, which has some page info, standard paginations stuff. Has a nice page, and then it's cursor based, so use that to fetch future pages. And then edges would be the list of things in this particular page. It's like super normalized, and if your model isn't as complex, or you don't need data that's that big to require pagination, you can get by with a lot simpler things, especially if your data is not graphically moving. But that's what that means. Yes?
Does it automatically put in this pagination?
No.
Or that's something you have to design?
No, it's up to you. But there's conventions for how people tend to do it, but there's no, it's not opinionated.
So you could make all films you could make a version of this that didn't do any pagination, but it would be some pretty happy queries.
Yep. So you'll see it in a little bit, but basically in your fields, if they can have a resolve function, and in that function you can do whatever you want. You can make a query to a database. If you know it right there, you can just return it yourself, or if it's part of something that was passed in, then you could just transform that little bit, or it doesn't even necessarily have to reflect the data that you have. You can have virtual fields that you compute on the fly, or you can make calls out to other services, which is essentially what you're doing in your database. And you don't, since you control the resolving, you can mix and match where data comes from. So you could hit Twitter here, Facebook here, whatever it is. For my work, we have a service-oriented architecture. So we have a suite of services which basically implement RPC type communication. So there's various commands, including commands for getting data. And my models behind the scenes basically make requests out to the other services, and then wait for it to come back, and then just kind of massage it into the shape that's requested afterwards. And you'll see it. Scalar fields you don't necessarily have to resolve yourself if they're in the context. It'll do that kind of smartly. And so in the easiest way, not necessarily the most efficient, if you just go grab your whole object and the GraphQL library will take care of just plucking out the things that the user requested for. If you want to get a little more complex, there are ways to see exactly what they requested, and then you could generate queries based on that to get much more efficient. And what a lot of people actually do is they'll put GraphQL kind of in front of a cache, which may then be fronting some of a variety of backend services, or maybe they'll talk to the backend services but have a cache over here or a cache in your thing. So what I actually did for my stuff is, so you see these queries could get kind of deeply nested, and there could be cycles, and so you could be fetching the same things multiple times. So what I actually do is, for a particular request, I have a way of hashing the calls out to the other services. So I make a hash for each unique one for that user's request, and if I've already gotten it, I don't fetch anything. And if I'm already getting it, I don't fetch anything. And you'll see it in a little bit, saying that. But the resolvers can also accept promises. So the promises are first-class citizens to this, at least for the node. And then there's analogous functionality for other languages. Okay? Then this GraphQL Viz is that other tool that I was mentioning. Actually, this guy, I don't know if any of you guys recognize this picture. He does some Bower stuff. But he saw my web app and ripped it out into the CLI version. But that's okay, because I'm a collaborator now. And it's a CLI version. You basically can point it at your API if it doesn't require authentication, or you can issue the introspection query yourself and download it somewhere, or if you want to type it through Perl or something and type it into GraphQL, it produces a dot file, GraphViz.file syntax, and then you just use GraphViz to transform it into whatever format you want.